Okay, that is how far you should have been able to get on 15 on your own. So we should be able to at least say that if my u is ln of t plus 1, then my derivative of that is 1 over t plus 1, right? We should all be able to get that. Then we should be able to say, well, that makes the rest of it the t dt part. And that means that the v is 1/2 t squared. We should all be able to do that. We should all be able to figure out what our u times v is.
Can you explain the arrow thing? Write it out like.
It's just how I organize the information. So u is this one and v is this one. So now I'm saying u times v is the next thing. And then the next part is the integral of v times du. So I'm drawing the arrows every time, not because it's like mathematically something, but it's most of you guys, if you connect memorizing a formula to like an action that you repeatedly do, then you're more likely to remember it. So I'm just consistently doing it the same way, so it will help you to remember that formula. Okay, so this part is definitely not a problem, right? Because that part's done.
Yes.
The part that's the problem is that once you fix this, you're not going to know how to integrate it. You're going to get stuck. So I went ahead with my integral, and I'm going to take that negative and put it in the, or I'm going to take that 1/2, sorry, and put that 1/2 in the front. And then that leaves me with t squared on the top and t plus 1 on the bottom. And this problem is not set up to do u substitution, right? If I was to do u substitution, I would have to say that the top was the u, and taking the derivative of the top is not going to give me the t plus 1 on the bottom. It's not going to give me 1 over t plus 1, like I'm stuck at this point. This is where we have to reach back into our brain and think, is there anything I've ever learned in math that could tell me anything about this problem? You have t squared divided by t plus 1. We can't separate them because it's the bottom that's a binomial.
Asymptotes.
Asymptotes, what else? What else does this make you think of? T squared divided by t plus 1.
You could do it.
Not derivative, because we're not doing derivatives, right? We're doing integral.
Inverse tan.
So it might make you think of that, but that might have, I think that's one with a squared. That has a squared in it. Does anyone think like actual division? Think of actual division. Can you do t squared divided by t plus 1? I'm talking about long division. Okay. So sometimes if you're taking the integral of something and in its present form you can't do anything with it, sometimes you could like mathematically do something else and then you can actually work with it. We're actually going to do long division on that. Okay? Ooh, what? Long division. So you're going to do t squared divided by t plus 1. So go ahead and work with the people around you, see if you guys can figure out how to divide that. Okay, here's my hint. The thing that you need to continue to do with this is you have to have plus 0t plus 0. So you actually have every single position like with a number in it. Yeah, we're doing long division with polynomials. Yeah. So what should I put right here? T. Yep. So t times t is t squared. T times 1 is t. I line those up and then I subtract each thing. So t squared minus t squared is 0. So I got that. 0 minus 1 is negative 1t. Okay, and I drop this down. What goes up here next? Negative 1. Because I'm asking myself the question, t multiplied by what is going to give me this negative 1? Yeah. No, that was positive t when I multiplied it. And then I changed the sign and that was me using my subtraction. Yeah. So then this is minus 1 right here. And then what do I do with that minus 1 up there? Multiply. So negative 1 times t is negative t. Negative 1 times positive 1 is...
Hey girl, come in.
Negative 1 times positive 1 is...
Negative 1. Positive 1.
It's just, is it Darius?
All right, so we said negative 1 times positive 1 over here was negative 1, right?
Yeah.
Okay. Now, what do I do with both of these signs? I switch them because I'm subtracting. So minus minus makes a plus. Minus minus makes a plus. So what happens with negative t and positive t? It's 0. What happens with 0 and positive 1? It's 1. All right. Do you guys remember with long division what you do with the leftover? Yeah. So I'm putting plus because that was a positive 1. And then it's 1 over t plus 1. And the t plus 1 is because that's what you were dividing by.
Thank you.
You're welcome. Okay. So here's what I'm going to do. I'm going to take this stuff that we had up here. We've got 1/2 t squared ln of t plus 1 minus, and I have the 1/2 in front of the integral, right? But now when I'm integrating, the thing that I'm integrating, I took from this and another form that equals the exact same thing but looks totally different is the t minus 1 plus 1 over t plus 1. So t minus 1 plus 1 over t plus 1. The reason that helped us in the problem is because we know how to integrate t, we know how to integrate 1, and we know how to integrate 1 over t plus 1. So we couldn't integrate it the way it looked before, but we can integrate it the way it looks now. Does that make sense? Okay. I am not a jerk, so that's a bonus type question. No, you're not done yet. Now you got to actually integrate it. Don't forget, you got that 1/2 in the front that's going to need to distribute when you integrate these things. This is where I usually split these apart and say this is negative 1/2 times the integral of t. Negative 1/2 times positive would be positive 1/2 integral of 1, and then negative 1/2 integral of 1 over t plus 1. That's what I do just to make sure that I make the 1/2 go with everything. Otherwise, I tend to forget that that 1/2 is supposed to go all the way through. And I distribute it as a negative 1/2. That's why I changed my sign in the middle. That is a tricky problem. They are not all like that. Right? But that's... I'm not evil. That's a great bonus question for a test, though. Just saying.
Yeah, and I will not be doing it.
I'm just calling the people. Yes. Okay.